Good afternoon. Today is the 5th lecture for the module 5, which is ongoing on remote sensing and GIS and its applications. So today's session is on geospatial technology for urban and regional planning. Now over this session, 1 hour long session, I shall be deliberating on these components. I'll speak on the definition. I'll lay the importance of urban planning using geospatial technology. Then I'll spell about some of the innovative technologies for the urban planning, what are the data required. Then I'll also briefly touch upon some of the basics of the geospatial technology and its applicability for the urban planning. What are data sets available for urban and regional planning, and what is the future trend? Later, in the second part of this 1 hour session, I'll speak about some of the applications in urban and regional planning and how the government is using this technology in various development programs. At the end of the lecture, I'll speak about the upcoming trend, that is spatial data cube of urban environs, where how we can quickly derive the data and we can straight away go to the analysis processes. Then I'll complete this 1 hour deliberation while speaking about what is the data needs for and the upcoming data as required for urban planning in future. So let me begin with some of the basic definition. When we say urban, as per Census of India and 2001 and 2011 census, the urban areas are characterized by higher population density and infrastructure in comparison to areas surrounding to it. It may be cities, towns, or conurbations, which excludes the rural settlements. Now, these urban areas that will include any statutory place like municipality, corporation, cantonment board, or notified town area committee. Areas. Now, otherwise will include those areas which satisfy the criteria based on population enumeration, that is a minimum population of 5,000 and at least 75% of the male working population is engaged in non-agricultural pursuit, or a density of population of at least 400 persons per square kilometer. That means it will also include the cities, towns which have got a population of 1 lakh and above. While we are speaking much about the urban areas, you may notice that in the recent decades, there is enormous growth in terms of areal extent and also the population. So in such cases, we require the land for expansion of urban areas. And in this context, the regional planning is also come into the picture. As such, the regional planning is well known, but for the benefit of the audience here, I'll speak about the regions are nothing but they are the portion of Earth's surface where physical conditions are homogeneous. It will range from a single feature region or a compass, that means a group of units together forming a region. So that will all be which have got the homogeneity, and that's how they will be delineated, and then they will form the region. So once this kind of regional planning also comes into the picture, its planning will help us for the much carrying out the urban planning in better fashion than without laying the importance for the regional planning. With this, I'll also lay the importance of how the urban areas are categorized. Urban areas are basically categorized into 4 categories. They're called as statutory towns, census towns, urban agglomeration, or outgrowth. Now, the statutory towns are the towns which have got, as per the act of government, which have got a municipality, corporation, or cantonment area board, or notified town area. All such places, they are called as statutory towns. We have previously seen the census towns where all 3 criteria, that is a minimum population of 5,000, or the census population, as per the census definition or the census data, 75% of male working population engaged in non-agriculture pursuit, or the population density of at least 400 persons per square kilometer. With this all criteria is met, they are called as census town, as we have seen in the previous slide. And this is how the urban areas are classified into 4 categories. The third category is the urban agglomeration, which is nothing but a continuous urban spread of comprising one or more towns and their adjoining outgrowth. So there are several examples. In fact, most of all metros in the country, they have grown much larger in nature and encompassing several towns in the periphery. They are all satellite towns in periphery which got merged into the metropolitan region. So they're all good examples of the urban agglomeration. The fourth category is the outgrowth, which is nothing but areas around the core city of town. For example, railway colony, university campus, port areas, etc., which are outside the town limit. But because of the certain government intervention and policy intervention, or because of some infrastructure facility which have come up, so the surrounding the settlements which have come up, that forms the outgrowth category. That's how the urban areas are sub-categorized. Now, if you see here that the towns, as per Census of India, at decadal interval, all this census enumeration happens, and accordingly, towns and the number of towns and their subcategories, they are notified. They are quantified. So if you look at the data, as per 2011 census, there were 5161 towns are there. But as per 2011 census, the number of towns have increased to 7935. Okay. With that point in mind, you will see that our urban population, as per 2011 census, was nearly 31.16%. And it is expected that with the way the urban areas are increasing, we are going to touch nearly 40% of the urban population in 2030. If that is so going to happen, now the issue is this, because the urbanization is inevitable, because for the reason to drive the country, economy is important, and the major drive or the push comes from because of the industries, because of the commercial activities and economic activities. For that reason, the urbanization and related process, as per 2011 census, they were constituting nearly 63% of GDP. Now, this contribution is going to increase to nearly 75% of GDP in the times to come. If that is so, that means urbanization is inevitable. But there are the challenges. What are the challenges? We have to keep, with the pressure on urban areas, we have to increase the facilities. That means, if that is so, then there is a, one can say about that the 80% of urban area of 2020 that has to be built. Okay, and as per the comparison, if you make it a new city of the dimension of like Chicago, has to be built every year of that dimension, of that size, across the India in different parts of the urban areas, so that to match with the pressure which is coming out, and it's to match with the development as it is required. That is so as such, as I told, the urban areas, they are the engines of growth. They provide services and economies of scale. Okay, and we know it is contributing significantly in country's economy and employment. And then there's an important factor, that is the pull factor. Pull factor means if some person migrates from the rural to urban areas, looking at the facilities and the employment opportunities, etc., he calls back to his kith and kins, and then he asks and then inspires them to reach and then join him in the urban area. That's how the cities, they grow, and that's how the pressure on the cities built up. But in the other way, they contribute to the GDP or the economics. But with this pressure mounting on the cities, there are the challenges. What are the challenges? Lack of open space, inadequacy of infrastructure, there will be overcrowding, congestion, mushrooming of slums. And like you see, as per the 2001 census, there was 61.8 million population was residing in the urban areas, and this figure has significantly increased in the recent times. lack of drinking water and sanitation, and then they will see the filth on the street and the environmental quality degradation. If that is so, we have to find out the solution. That's how the urban planners in the recent times, they have understood the importance of geospatial technology, and in many of the processes this technology is being used. And in the subsequent slides we'll try to see how this technology can be used for some of the applications in urban and regional planning. Before I move on further, I'll just briefly touch upon some of the fundamentals which you have already read in the previous module, but I'll briefly touch upon what is its linkage with the urban and regional planning. As such, when you say geospatial technology, it encompasses several sub-disciplines like remote sensing, photogrammetry, LiDAR technique, where the data may come. There will be other ground-based measurements also where the data can come, but they have to be georeferenced. All this data has to be integrated within the GIS platform. You are already aware about the GIS, and then if all these data have to come, you require the GCPs. Now the GCPs will be helpful for putting all this data on a common platform, and also the GPS data will be helpful for assets mapping for urban areas. Now in the recent times, because the newer techniques which have come up for the data acquisition, that is the UAV, where UAVs, they fly into the near Earth platform, okay, and then acquire the data at very high spatial resolution, and that is very, very helpful for viewing the Earth surface at much higher spatial resolution than as compared to the data which is presently available from space-based platform. But only point here, there is one has to fly the UAV to acquire the data. And because in urban areas, because the information is not only required for over the surface, because under the surface we have got the utilities, and these utilities are at times, most of the time, they are laid almost several decades ago. So those information, they are not available typically in the standard map format. That's how the GPR data is also very useful, which is based on, again, microwave technique, and it acquires the data and brings into the common platform. And this data, using this data, one can map the underground utilities and then find out their characteristics. Okay. So as such, in the urban planning, what do we require? First of all, what is the purpose? We have to acquire the information, present information. Then based on the present information, then we have to apply our skill, and then based on the skill and the resources available, we have to reach to some planning stage. In that context, what is the information which is required? First of all, we require the physical parameters. What are the physical parameters? Physical parameters will be like road layer, the land use, land cover, soil, geological characteristics, hydrological characteristics. This all form the physical parameters. Then, because in the urban areas, then you have to find out how to optimally utilize the land use. A piece of land, parcel of land, how to optimally utilize it. That's how we have to prepare the plans. Okay, so plan is nothing but a document which encompasses the optimal utilization of land use based on policies which are framed by the government as per the wishes of the people. That's how the policies also come into the picture. That's how, if that is so, that's how the legal framework also comes into the picture. Then after all, this development has to happen for whom? It has to happen for the people. That's how the stakeholders' characteristics, their aspiration also comes into the picture. Then what we have to do, because all these operations so they have to be managed by the typical urban local bodies like municipal corporation or council. They have to manage their resources. That's how the physical management is also required, like property taxation, etc. is required to improve the quality or to provide the services. So that's how the 4 categories of inputs are required, and some of these information can readily come from the remote sensing resources like the physical parameters. Also, to some extent, about the other characteristics can come, and then that's how we can interpret the data. Right hand side, on this slide, you are seeing on the top two, you are seeing the relatively coarser resolution, and then bottom three, you're seeing the relatively higher spatial resolution, and you see that this how it is possible to segregate the urban areas into different land use, land cover types. It may be commercial, residential, industrial, so on and so forth. But how to derive this information? Now, this derivation information already you have gone through in the previous module. We can use either the manual image interpretation techniques, which depends on the elements of image interpretation, or we can derive the machine processing based information extraction. But only point here that extent to which the data shall be required for detailed plan preparation, all of these data cannot be automatically extracted using the machine-based processing methods. That's how the manual intervention or the image manual methods will be always taking the front seat in such exercise. But nevertheless, in some of the operations, particularly in the regional planning, the automated information extraction is still superior as compared to the visual interpretation when the information required is coarser in nature. Okay. So as such, why should we use the remote sensing data for urban and regional farming? For the first thing being, this is digital in nature, because currently the data is mostly digital in nature. So what we can do, we can find out, because the satellite data offers the temporal characteristics as well. In such case, we can derive the data for the previous date, for the current date, and also based on the trend analysis, we can also predict the future trend. Okay, that's how, because we have got the remote sensing data without any hearsay based information, we can draw the information for the previous and the present date, and also draw the future characteristics. As such, this all because the data is going to reside in the GIS platform, the data integration also is superior. Okay, so that's how the remote sensing data has got and it is gaining importance in urban and regional planning. As such, I'm putting up two curves here. You are all well aware that is called spectral reflectance curve. That is about how each object on the Earth's surface, particularly in this curve in the urban areas broadly, how they manifest on the satellite data. If it is the water body, beyond the near infrared region, the information will be reflectance will be subdued in nature, appearing darker in color. That's how we segregate the water body as compared to the other feature. When you come to the urban surfaces, because urban areas, they are brighter, they appear brighter in all bands. That's how when you prepare the false color composite, you're going to see them in either in the white color or in shades of white. Okay, when it comes to the vegetation, depending on the characteristics of vegetation, you're going to see the sharp spurt in the infrared region, and subsequently there will be some dip will be there that will be called as water absorption bands, and then that's how then one can segregate the water vegetation versus the rest of the feature. But they are all on the left hand side. You are seeing the broad spectral reflectance curve. On the right hand side, because you see there are variety of material that is being used for building the structure. So the upcoming technology, that is the hyperspectral remote sensing, where based on the material characteristics one can segregate the features. Okay, so that's how. So when you're taking up any planning, urban planning project, or for any other matter that any other project you're taking up, there are several characteristics you have to keep in mind. And what are those characteristics? One has to keep in mind the resolution. And you already know that the resolution, that means spatial, spectral, temporal, and radiometric. You have to keep in mind that what kind of data sets in terms of bands will be required. You got single band, multispectral, or hyperspectral. Date of pass is very, very important. You require the single date of pass, or you want to carry out the change analysis. That means several dates, data of several dates will be required. Then, depending on your purpose, then the satellite data resolution and also the scale of mapping will also depend. So if you are looking for the local area plan or for the site plan, if you are looking for the regional plan or perspective plan, accordingly one has to choose the scale and the scale dependent spatial resolution of the satellite data. Then one can choose about what kind of band combination is required. Typically, false color composite, standard false color composite is the standard product which is being used for interpretation. But to give it to the user, always we prefer the natural color composite. Then it comes to the interpretation, where depending on the objectives and the classification schema, one can choose the classification technique. It may be supervised or unsupervised, or the machine learning, or the advanced classifier based method. Then all this data has to come into the GIS, and subsequently you can also look for the chain detection. Already you are aware about the various resolution, that is spatial, spectral, temporal, or radiometric. Just to take a revisit, that the spatial resolution is nothing but the smallest object that can be resolved by the sensor. Spectral is that defines the number of spectral bands. Temporal is defines the time required to revisit the same area and acquire the data. And the radiometric resolution that governs the number of bands and the range of numbers. Each of these resolution has got the deeper implication about the kind of data you're going to choose, and subsequently kind of information you're going to extract, and your purpose. That's very, very important. So as such, when you talk about the spatial resolution, broadly it is put into three categories, particularly in the context of urban planning, because what enthuses us when we are when you're going to see your own individual entity, your house or structure, when you see, that's how the commoner gets into and then likes the data. Okay, that's the very high spatial resolution. That means some meter data has gaining very high importance. As such, from the perspective of spatial resolution, it is put into three broad categories. That is the low, medium, high. So low resolution means the resolution is coarser than 30 meter, medium means 4 to 30 meter, and high means finer than 4 or superior. No, I mean it will be some meter category that will be called as very high spatial resolution. So as such, Indian Space Research Organization has launched several satellites which are already in the orbit. In 2019, we have launched Kato 3 satellite, which has got the spatial resolution of, which has got two major sensors, that is panchromatic, where the resolution is 25 centimeter and it is single band, where the multispectral resolution is 1 meter, nearly 1 meter. Okay, and that's how it is. Using this data, we can map the Earth surface at much higher spatial resolution. In the times to come, we are going to have several of the satellites, and those will be HRSat, NISAR, GISAT, and then ResourceSat upcoming series. And we're going to see the newer generation satellites like the IIRS sampler, etc. Okay, so we are going to have several satellites and missions which are planned, which have got the importance for urban and regional planning. As such, already we have got several satellites which are the data which is presently available, and they belong to the very high or very high spatial resolution category. And of importance, I'll particularly mention here about the Cartosat 3 or the Worldview series of satellites. There are other satellites as well, like the Spot or the ComSat plates, etc., which are providing the data of very high spatial resolution. So point here that I'll also emphasize here that in terms of the cost characteristics, Indian remote sensing data, they are much cheaper in nature as compared to the foreign satellite data. Typically, any foreign satellite data, when you're taking it, the archive product typically will cost nearly $10 per square kilometer, whereas Indian data, for example, if you're taking the Cartosat 1 data of a typical frame of 27 by 27 kilometer, its cost will be nearly 6,500. So it's how that it comes out to be much cheaper as compared to the foreign satellite data. But with the recent all happenings, we are going to see much. Several other activities are going to come in near future. We are going to see in our skies, in our orbits, orbits. We are going to see several other satellites which are going to provide us data from the Indian platform, which will be much superior in nature. Okay, so as such, now we are moving to the stage where people are asking. Typically, when you procure the data, then one has to procure the data or download the data. Then you have to start the processing. After processing, one has to carry out the analysis, and that's how the information is extracted. So these are several stages are there. Then we are reaching to a stage where people are asking, is there anything called ready to use data? That's how, and also where the data can be used, that can be made available easily. That's how the emphasis is laid on open source satellite data. There are several platforms. I guess some of you might have used the platform called Earth Explorer, or from the NASA platform, or also from our own Indian platform, that is Noida, NOEDA, which is a segment of Bhuvan, where you can download the list 3 and allied data sets for free. Okay, there are again because we have got over the several decades now, Indian Space Research Organization has prepared a wide and varied database of our Earth surface. So that's how these databases, they are hosted on Bhuvan platform. There are other platforms like IndiaVaris, BIS, IBIN, or other data platforms where ready-to-use data is available. Now, these all platforms make you available several of these data sets. So if you're looking for the disaster management support kind of data, one can visit the several other websites like the NDEM or the GIS resources. Then, because in several of the analysis like the hazard and risk analysis, we also require the meteorological parameters, where all such data can be extracted from MOSDAQ, WorldClaim, or the TRMM kind of websites, where all these data are available for download. So we have also looking at the importance of this all ready-to-use data. There was a project which was undertaken almost 1 decade ago. It has started, and we have got the data for 150 towns available in the country, and which was developed under under the project called NUIS, National Urban Information System, which was aiming at creating the data sets for across 16 categories, out of which 12 categories were the primary layers and the 4 categories are the incorporated layers for 150 towns, and it was meant for building the master plan for the several cities in the country, and it is meant for the e-governance purpose. So this was the one such endeavor by the government to create the database, and this kind of data should be readily available to the urban planners for such kind of purposes. Okay, so as such, the data is not only available from the optical platform. We have got the data from other platforms like LiDAR, microwave remote sensing, thermal remote sensing, and hyperspectral remote sensing. They have got their own importance. For example, LiDAR helps because the LiDAR amplified signals, they hit the top and bottom of the structure. If that is so happening, based on the echoed energy, one can find out the height of the building. So that's how it is superior method for building the 3D city model, and the such data, though they are presently scarce, because the data as such, currently we have got the satellites like the ISAT 1 and 2 and the ZI, where the data sets are available, and then but because still their footprints are still coarser, but even then they have got the importance. There are some data sets which are available from the airborne LiDAR platform, but they are restricted in nature. But if you use such kind of data, you can extract the building heights to the extent which have got the accuracy of nearly 20 centimeters. Now, another data set is the micro remote sensing, where because the building, they act as corner reflectors in the micro remote sensing data. So it is the kind of ready reckoner for identifying the built up surfaces. The next important data source is the hyperspectral remote sensing data, because when you are seeing the urban areas in tiny spectral range, so based on the wavelength characteristics and its interaction with the urban material, each kind of surface will be behaving differently in such tiny spectral range. So that's how one can find out the urban material. And there are several studies are there. Again, the data is scarce in nature, but in the times to come, you're going to see the high spatial resolution and high spectral bands, which will be going to be very useful for studying the urban material. Now, as the natural surfaces, they turn into the built-up surfaces, their thermal regime also changes. As you're seeing in the graph here, you see that how the temperature regime is changing as the natural surface is changing the built environment. Such kind of phenomena is captured by the thermal band. That's how, based on the building density and based on the urban microclimate kind of analysis, you can see the temperature profile of the city. So that's how the thermal bands are also very, very useful. Another technology, as I said earlier, that is called the ground penetrating radar, which is nothing but the non-invasive technique for subsurface exploration. What it does, based on dielectric constant of the different material underneath the surface, what it does, it emits the signal, antenna emits the signal, and the echoed energy, it is again recorded by the sensor. Now, what is happening, because of the frequency at which the signal is emitted, and also because of the dielectric properties of different material, where the water will be nearly 80, and then the air will be 1, and the other material, they have got the dielectric characteristics in between. You can find out the depth of the material, different material. You can find out if the pipe is there, it will be behaving differently as compared to any rock or soil surface. It is going to it is going to demonstrate as hyperbola in the radarogram, and also you can also find out the diameter of the pipe and other characteristics. There are literature available for such studies. Okay, so the next dimension of remote sensing is the temporal resolution. That's how one can easily visit any open source platform, and you can see like the Google Earth, you can visit, and you can find how the surface manifestation because of human intervention is changing in any part of the city. And you can see that how the built-up surface has got increased over the nearly 18 years period. Okay, so it's how the temporal resolution is very, very important, and it has got importance. For example, the plan has been prepared, it has been enacted, and there would be certain violation or otherwise permitted category. That's how you can see the change, and they can also visualize, if you are in the GIS platform, what was proposed and what is happening on the ground, with the ask also confirm some ground based experiments, and then you can see what has been proposed and what is the change which is really on the ground. Okay, so it is another classic example how the temporal satellite data that is going to help us in visualizing the changes which are happening on the ground. You see that this is the part of Ahmedabad city and the Sabarmati river. Because of the government intervention, it was the unplanned surface on the both sides of the river. What the government did, looking at its strength and also understanding its importance, each side of the river has been drained, desilting, etc. has been done, and that's, you can also see the before and after image, ground photograph also. So that's how the recreation space has also come up, and it will be certainly going to add to the revenue to the government and also bringing some kind of income to the people. Okay, but this is how it is being captured by the satellite data. Now, with this background, let me move on further how this such kind of data can be used for the urban planning. Typically, when you go to any planning system, no, we start with the perspective to the regional plan, then to the development plan, to the local area plan, and the special purpose plan. Okay, that's how, with the increasing scale, that's how the information extraction information is desirable, and how the plans are prepared at the national or regional level or at local level. Of course, at local level, we prepare the plan at a very high or large scale, but in the regional or perspective plan, we prepare the plan at much coarser spatial resolution. But if you're doing so, we require the information at matching scale. So when we say matching scale, then it has also got the linkage with the spatial resolution. That means if you're doing with the macro scale, that means regional or perspective plan, that means it would be something of the order of 1:50,000 or much coarser, where the low spatial resolution satellite data will be suffice. When you go to the micro level plan, that means project area or site plan, then we require high spatial resolution or very high spatial resolution satellite data. Why so? Because our information need is also changing. For example, if you're going for the macro level planning, we require the land use, land cover at level 1. If you go to the meso level, that means district development plan, it will be level 2. When you go to the micro site level plan, then we have to go to the level 4. What is this level 1, 2, 3, 4? It is nothing but the information content. In level 1, we'll say urban areas as built up. That is a single class. When you go to the level 2, then what we'll do, we'll say built up area further categorized as rural, residential, industrial, commercial, and recreational. When you go to the level 4, we'll further categorize the urban areas into high rise, medium rise, low rise, and so on and so forth. Okay, that's how the information, as the scale changes, as the planning term changes, corresponding scale changes, and corresponding the information content also increases. That's all. Now with this, let us see how we can interpret the satellite data. Now you see the top 2 and bottom 2 images. What is the difference? You can see that the top 2 images, no, they are well structured. Their geometry is very, very homogeneous. But the bottom 2, when you come down, you see the geometry is not so well organized, because that's how we call them as planned and unplanned. Now within the planned or unplanned surfaces, based on their density of the built up, we say high density or low density. That means planned high density, planned low density, unplanned high density, unplanned or low density. The same satellite data is further being used for preparing the land use, land cover. So now, typically the satellite data gives us the land cover information, but the land use largely comes from the grounds, and accordingly we attribute the polygon as commercial, industrial, transportation, institutional, residential, and auditorium. So if you see here that auditorium means there has to be some kind of defined geometry has to be there, and then commercial defined some geometry has to be there. And again, you're going to see the array of shops and etc. etc. When you go to the industrial, there will be some industrial sheds will be available. Then there will be effluent which will be coming out. When you go to the transportation, you're going to see some kind of transportation network in the part of the image or that polygon. When you go to the institutional, there will be a typical layout. That means the building, in the well organized, we are going to see in the center of a single or group of buildings, and in the vicinity going to see the open spaces, and we are going to see a road which is connected to the main road. And the most easiest to identify is the residential unit. Then based on the array of houses, one can find out the residential category. Now another category would be the auditorium, that will be defined based on the shape and also from the ground. That's how we categorize, identify and derive the information. Now, you see, often we based on the pattern of the road. No, that's how the city structure is also defined. And for example, I need not tell you which part of the country it is. It is having the grid plan or the grid iron pattern, and that's how you see that it's a well-laid geometry of the roads, and that's how the well-planned surfaces they are there in Chandigarh city. That could be another kind of plan that will be called a radial plan. That's how the radial plan is with there, with it has got a single nuclei, and then all the roads they finally converge to the central point. Okay, and then they come out radially from that central point to the outward circuit. Okay, so with this, how we have learned that how to extract information. Now in the next few slides, we are going to see what are different applications. Broadly, when you put into that, what are the different applications of urban regional planning, it will be sub-categorized as inclusive planning, urban governance, urban environment, regional planning, heritage conservation, urban design, urban utility, urban hazard, etc. So how the remote sensing data will be useful, we just see some pictorial journey, how such application can be done. Already you have learned that land use, land cover preparation. Now you see is a is a standard false color composite, and based on elements of image interpretation, the visual interpretation has been done, and then the land use, land cover mapping based on standard classes, that is residential, commercial, and then religious, and then educational facilities, they have been mapped based on ground data, and also polygons have been devised based on the pattern and the other attributes we are seeing on the satellite data. Once we have done it, because the informal settlements of the squatters are also integral part of our society. So that's how such kind of high spatial resolution satellite data can be used for finding out carrying out the slum mapping. Now, when you're doing with the slum mapping, there are the challenges because the houses within the slum area, they are so close by. It will be very, very difficult to map the building footprints. So we have to, and also their attributes. Now, such attributes will be not only the building footprints, we have to also find out their characteristics in terms of sanitary, rooftop, or their roof types, or the wall categories, etc., etc., and then their socio-economic attributes. So, as such, I said, no, the remote sensing and it is one of the tool under geospatial technology, where the data from the remote sensing and also from the ground together it comes, and then we try to integrate it into the GIS platform, and then finally for such kind of slum or squatter areas, we try to carry out their planning processes. So because using the remote sensing data, we not only try to extract the 2D information, we also try to extract the 3D information. Now, 3D information can be extracted with using the manual processes or using the automated method. Now, the manual process is because what is happening during the time of data acquisition, each building casts its shadow. Now, the length of the shadow depends on the height of the building. Now, with this narrative, what one can do that based on the trigonometric principle, one can measure the length of the shadow and also the solar elevation angle. When you do it, you're able to find out the height of the building. That is how the manual methods are deployed for finding out the heights of the building or number of floors within any urban area. But there are automated methods as well, where using the digital photogrammetric technique and using the very high spatial resolution satellite data or based on LiDAR remote sensing data, one can find out the height of the building, and the 3D city models can be done. Once we have done it, then also we can carry out the space use mapping. So space use mapping is nothing but that demonstrates how a piece of land has been used horizontally as well as in vertical directions. So if you do it, you are able to find out that there is a single story, because based on the height of building and based on standard height and standard height of the floor in any typical areas, we can find out how many floors are there. If that is so, then you can find out what is the dwelling, and based on typical dwelling size, you can also compute the population. That's how the Census of India has also laid the importance of remote sensing data into the population enumeration, where some kind of sample survey is done for population enumeration. And once you have done it, one can also find out also the floor area ratio, that is nothing but the total built up area upon the total plot area. So once we have done it, then this can be used for urban governance purpose. Now, within the urban governance purpose, the property taxation, as I said, is a very, very important process that helps the urban local bodies to meet the financial requirement, and also to improve the services within urban areas. Now, there are several methods for property taxation. So typically, such methods, they are based on either the rental value method or based on the capital value method. But an important method that is called unit area method has come up, which is far more extensive in nature, because it not only depends on a single criterion, it depends on several properties like use factor, occupancy factor, age factor, and structural factor of the buildings in an area. So that means if any building is very, very old, that means tax that will be levied, that will be much lower as compared to the building which has come up recently. So what we can do, you see here that we are showing 3 parcel of urban areas. Okay, on the top left you have got you can see there's all 3 areas, they've got different attributes of the city. First, top left is showing very well planned urban surface, where the geometry is very, very homogeneous and the houses, they are far apart. Bottom B, when you see, the density of the building has increased, and the right hand side, when you see, you will also see the association of the buildings along with the river. Okay, so as such, based on this, all such kind of attributes which are identified using the elements of image interpretation, we try to find out the social strata of the society. Accordingly, such attributes help us to find out the parameters as are required for unit area method, that is the use factor, occupancy factor, age factor, and structural factor. As such, it is not possible entirely to derive all this information using the remote sensing data in such cases, we use the conjugate. We have the conjugate use of remote sensing data and also the ground truth to derive all such information. Once we have got this kind of information, then it will be very helpful to use the unit area method. I mean, you must think of it that if the remote sensing data is not there, one has to depend entirely on field-based method, where mapping of 1 hectare of area is going to take very, very longer time as compared to the remote sensing based method. Okay, so in the recent times, now we are going to see, as I said, that the newer applications are coming up. So I'll just over the 10 or 15 slides, I'm going to show you some of these applications which are hosted on different platforms, or some of these applications have been carried out at IIRS. Okay, so one such application is the tourism GIS, which has been done and which is hosted on Bhuvan platform for the city like Amritsar. Very database as required for tourism GIS. They have been mapped and hosted on an interactive platform within the Bhuvan domain. Another quite interesting information is the municipal information system, where ward at house level kind of information, they have been hosted. Now this work has been carried out for the part of city where Ludhiana Municipal Corporation, which falls into the Ludhiana Municipal Corporation, and it was particularly meant for the urban governance purpose. Okay. Another interesting area application is the location-based services. You see that Remote using the GIS aided with remote sensing, one can map the utilities and facilities. Once you have mapped it, then you can see its relative concentration in different part of a city. So once you have mapped the relative concentration, then based on the you can also do buffer based analysis to find out the service or catchment area or command area for each such kind of entities. Then one can find out quickly the areas which are devoid of such facilities. Once we have done it, we can find out the gap areas, and accordingly the planning measures can be taken. Okay, or otherwise, based on the time and facilities, no, we can take the all these categories, that means X, Y, and also the time. Then we can find out that if suppose any fire has occurred, then how much will be the travel time for a fire a brigade to reach the spot and quell the fire. So that's how the location-based services, they are gaining importance. Another interesting example is the urban sprawl, because as I said in the beginning that the cities are growing. Now, when the cities are growing, because the remote sensing data offers us a unique source where we can map any parcel of the Earth's surface in temporal domain. Like here, when you see the city, Dehradun city, over the its growth in across direction, in several directions, how it grew and what it is implication, that can be mapped with the urban sprawl analysis. Okay, so once we have done the urban sprawl analysis, then you can also do the growth modeling. So the growth modeling is nothing but seeing the trend of urban sprawl and then projecting for the future. Okay, so it has got importance because it gives a platform to the urban planners, to which direction, with the current policy in place, which direction the city is going to grow. If that is so, now the progressive cities, they can devise methods to create the facilities which are matching with the upcoming city sprawl. Okay, so that is so what we try to do, that we try to create the scenario, because GIS helps us to create the scenario. So what we try to do, we try to create three kind of scenarios, that is baseline scenario, compact growth scenario, and a hierarchical growth scenario. The baseline scenario means business as usual. That means the way city is growing, let it grow. So what will happen? City will grow. First of all, there will be densification in the existing city, and then there will be sprawl into the surrounding. Suppose the planners say no, it is not possible to grow any further. Then what will happen? That in such case there will be compact growth scenario, because the land use does not permit the allowing the built-up growth to happen in other part of the city. In such case, the vertical rise will happen, and also there will be densification. That's how the compact growth scenario will happen. But suppose the urban planners, they want to look at another scenario, that is the hierarchical growth scenario. That means let the city has grown to an extent where any growth further is not advisable. So the planners can think of, let us have a satellite town in vicinity which can be allowed to grow, okay, promoted to grow, so that a kind of mass rapid transport system can be developed which can connect the city. So such case, hierarchical growth will happen and there will be lesser load on the existing city. So this kind of scenario generation can happen with the urban growth modeling, and there are several techniques for the urban growth modeling. It all depends on the kind of data which you have and what kind of drivers we are going to ingest into the planning process. Okay. Now, another classic example is the energy potential, particularly the solar potential assessment. As such, satellite data helps us to map the building footprint. It also helps us to quantify the solar radiation which is falling on the surface. Okay, so both these attributes help us to find out how much energy is going to what is the flow, rooftop area, and also how much the energy is going to fall or can be trapped using the rooftop solar power plant. Now you have got the rooftop area multiplied by the radiation. If you do so, then you can weigh and multiply the efficiency. Then what you can do, if you are doing it, then you can find out how much energy can be tapped, you're using the non-conventional energy resources, that is the solar energy. Okay, so that's how much energy can be harnessed. The remote sensing data is becoming very, very popular technique. Okay, but because such kind of energy tapping can also not only happen on the rooftop, it can also happen on the open ground. But only point here that it is much economical in nature to put on the rooftop, because land resources are scarce. If you got the land in plenty and you're looking for the larger plants, okay, then you also look for the solar farms. Okay, another example is the utility management. No, see, as I said, within urban areas, several utilities like the water or electricity or any services, they are laid beneath the urban surfaces. Okay, roads and other surfaces. So what one can do, because typically what is happening as the urban densification happens, pressure mounts particularly on the water and supply of water. Now, typically the utilities, overhead tanks and reservoirs, they are got it live. Typically they have got a life of 30 years. Okay, so by the 30 years or before that one, because of the mounting pressure on such services, what will happen, that there will be pressure, and then and some of the areas within that city, they will not be receiving the enough water. That's how typically such pressure mounts that the urban local bodies based on the need, based on the social character, social and other reasons, they come out with the newer water utilities. They install it there, and it's how the facilities augmentation happens. But there are geospatial techniques, based on which you can map the underground water utilities. You can map the over the ground overhead tanks and the sumps and reservoirs. Then you can do if you have got the land use land cover, that means beneficiaries location, how the houses are located, and then you have got the pipelines, then location of walls, etc. And then you can find out how much at each node level, how much the head is required. Okay, that means the head is required, that is nothing but the head loss. Okay, using the standard equation. If you have done so, then because the head is a function of pressure, so you can find out whether the pressure has gone negative or it is positive in nature. So there are hydraulic software which are embedded within the GIS, which are quite helpful, and several urban local bodies in the city, they are mapping the underground utilities using existing data and also using the GPR to create the water utilities database, and that's also envisaged under the programs like Amrit, to map these facilities and also to assess the present and future water demand and to plan there, because any kind of facilities augmentation typically requires, first of all, understanding the problem, preparing the DPRs, then sanction of the DPR, and then implementation takes much longer time. If you've got such kind of utilities, you can plan for the future and you can create the facilities in advance rather than allowing the people to be in need for several years and then create the facilities much later than when it is really required. Okay, that's how the technology has got its own importance. Already I've tried to explain to you the application of thermal remote sensing. As such, as I told earlier, that as the natural surfaces turn into the built up, the thermal regime also changes. So what one can do using the thermal bands which are present in several satellites, that can be utilized and based on some kind of data processing, okay, and then that's how the land surface temperature can be mapped. And you see this how we can do the land surface temperature LST mapping, and one can also identify the pockets where the UHI phenomenon is happening, or the very unusual temperature rise is happening, which causes the thermal discomfort to the local city dwellers. Okay, already I've tried to explain the applications of the hyperspectral remote sensing. So if you got the data of if you got the data which is present in the hyperspectral remote sensing domain, so what one can do, one can find out the urban material, and then once you have got the urban material, then you can find out its attributes and also its correlation, how it behaves across different spectral range and wavelength. Okay, so another interesting applications is that, because after all the areas within in a city is fixed. So unless the city is sprawl, the area is fixed. So there are vacant lands. So typically once any urbanization happens, it eats up the land in the vicinity. Then typically the victim of such kind of land use are the water bodies or the green spaces. We try to do several analysis. Already in the literature, it is reported that several cities in our country, they have lost the water bodies because of the pressure casted by the urbanization processes. Okay, so we try to see, and you see that we are trying to create some kind of animation that some of these wetlands in some of the metro cities in our country, they have been encroached upon, and how the newer urban setup they have come up. You can see here. So we try to map using the data which is available in since 1960s, late 1960s to the recent times, and we try to demonstrate that how the water bodies they are dwindling. So we try to prepare some kind of much authenticated database that how the water bodies they are dwindling in a city because of urbanization pressure. So if that urbanization is happening, then they have got its own repercussion. Repercussion means typically such kind of water bodies, they act as cushion, sponsity, such kind of phenomena you might have heard about. So they act as reservoir. So whenever the excess rainfall comes, they absorb these kind of excess rainfall, and in crisis time or in the lean time, those water can be again utilized by the city dweller. So that's how in several cities in our country, they are facing the urban flood risk. So one can do the urban flood risk analysis based on hazard analysis that can be carried out using the hazard analysis based on different magnitude of rainfall, and also finding out the vulnerability analysis based on the socio-economic attributes of the dwellers. Once you can multiply these two factors, then you can find out the risk for different magnitude of the rainfall. If you have done so, then you can match it with the capacity of the urban drainage system. Whether the drainage system is capable to evacuate the water which is going to come due to the peak rainfall conditions. If not so, then remedial measures have to be adopted. Otherwise, there will be several instances of the floods where the roads and the streets, they will be choked. People will be forced to travel on the boat, on the street, okay, or there will be river overflow and the backwater flow from the river into the city will happen, and then all urban ecosystem will get disturbed. So with this, I'll try to put very brief on the regional planning as well. I have already laid the importance of regional planning. Here in a case study, I'll try to demonstrate how the remote sensing data and GIS can be used for regional planning purpose. Typically, you see, any city, when it grows, this is the current extent of the city. When it grows in the vicinity, and suddenly, first of all, the growth will be linear in nature, and in the later part, subsequently subsequently the densification happens and the satellite town gets merged into the existing city. That's how the usual process happens. But if that is so happening, then the uncontrolled process has to be taken into account. That's how the regional planning has got its own importance. What we try to do, that Chandigarh city is well-planned, well-known city in our country, and it was envisioned with different kind of sectors. You are aware that has got a grid plan, and then it is well known that it was put into several sectors. Okay, and then it has where the sector 1 to 30, which was envisaged to be low density, and then the sectors beyond 30, they were envisaged to be little higher in density. But what is happening, that the satellite towns in the vicinity, Mohali, Zirakpur, and Sasnagar, etc. So they're all they are growing because of the limited policy intervention. So what is happening, that because of the growth which is happening in the surroundings, the city itself is growing. Okay, and after all, the people they for their economic activities they move to the Chandigarh city, and that's how the traffic and other related issues they crop up. So that's how the regional planning of Chandigarh is very, very important. As such, when the city was planned by the Lee Corbus here, it was planned at 16 kilometers beyond the existing city. There should not be any development, but already this kind of development has happened. So what we try to do, that based on urban growth modeling principles, we try to map the first of all map the growth of the city in 2 decades back to the recent time, and we also try to see its growth in the future. Once we have done it, we try to see in such kind of growth when it is happening, then which direction the city will grow, and then when the city is growing, then which are the towns or cities which are going to be engulfed or going to be merged with the existing city. So that's how we try to find and devise the proposed boundary for the greater Chandigarh region, which is that was our recommendation, and then we have come out with the publication. That's how this shows an example where remote sensing data and GIS can be used for regional planning purposes. Now, as I said in the beginning, the government of India has given the importance to geospatial technology, and some of the flagship program of the government of India, particularly of the Ministry of Housing and Urban Affairs, its program is proposing the utilization of geospatial technology. For example, in the Smart City Mission, which is proposing, and the program is ongoing, where particularly for the base map preparation and also putting all the information into the GIS domain and its effective utilization has been envisaged. Under the program called Atal Mission for Regeneration and Urban Transformation, that is AMRIT program, which is planned for 500 cities, and recently the government has come up with the AMRIT 2.0, which is aiming towards across 11 reforms for improving the quality of services within the city and also for the master plan formulation. It is laying very strong emphasis on the geospatial technology for the master plan formulation and also for the GIS-based database creation. Under the Swachh Bharat mission, the mapping has been proposed, and also the app development has been proposed and has happened across several cities in the country for effective management and waste disposal. Under the Hriday, that is envisioned for the 12 heritage cities in our country, mapping using the remote sensing data, particularly the 3D mapping of heritage and monument sites have been defined. Okay, so that's how the program and Government of India program they have laid the importance. So as such, if you visit the website of Smart City Mission, it has got the 4 strategies for implementation of the program, that is retrofitting, redevelopment, greenfield, and planned city development. I'll just show you, particularly on the visualization purpose, that's how the urban redevelopment is happening. A typical example is the part of the Mumbai city where dense and crowded and low space utilization presently. That's how it is being planned for high-rise building, which has got facility for good parking, ample spaces, and vertical structure. So such kind of development is happening, and we try to capture using the remote sensing data. That's how over the period of time existing structure has been dismantled, and you can see the high-rise structure has come up, and that's the kind of exercise taken up under the urban redevelopment. Okay, another example is the greenfield development and a city in the eastern part of the Asia, where Songang city, where the reclamation has happened. Okay, and after the reclamation, the land has been reclaimed, and the Songang city, which is a very good example for the smart city, that has come up. Another good example is another retrofitting example, that means increasing the facilities and the services. You may see here over the period of time, that's how the footpath, on either side of the road, a good footpath has come up for the urban dwellers to walk and to traverse and doing the morning routine activities. That's how the either side of the road footpath has come up. Okay, so these are the good examples. Under the Pradhan Mantri Awas Yojana, individual houses, they have been geo-tagged using the GPS with the photographs, and then they have been put into the GIS, and this is available for visualization purpose and also for the query purpose on the Google platform. Another example is the Atal Mission, where, as I said earlier, for improving the quality of the services within urban areas, where the Indian Institute of Remote Sensing, IIRS, is very deeply involved, where we have developed the geospatial technology based training and capacity building, and also for preparing the maps at 1:4,000 scale and formulation of master plan. And NRC ISRO is deeply involved in satellite remote sensing based database creation. Now this database will be finally handed over to the urban local bodies for master plan formulation. Under Hriday, as I said, with the 12 cities across the country, their 3D city visualization and also the ICT based solution, they have been proposed using the geospatial technology. As I said earlier, that the Swachh Bharat Abhiyan, development of the mobile apps and the geotagged photograph, they have been devised. I'd like to mention here that as the quality of services within the cities, they are improving. There are benchmarks. In the Western world, there's a ISO called ISO 37120, where several indicators, they have been developed to quantify the services and to qualify or to rate them to become as ISO qualified cities. Let us hope that cities in our country also, they improve their services and provide better quality of life of our city dwellers in our country. Okay, so now I like to conclude now. As such, the information content is rising, applications are rising, and government has also adopted the technology. But we are coming to the time where people are asking about the ready-to-use data. That's how the spatial data cube has come into the fore. Its importance has been realized. As such, when we say remote built-up areas, they occupy 3 to 4%. Now we have got the temporal remote sensing database, and dedicated database has been developed that is called global human settlement layer, and also the database like nightlights data, they are quantifying very ready to use data people have used. And then what the researchers have done, they have tried to quantify the built up surface over the period of time. And these kind of ready to use data sets, they are being developed under a consortium of group of countries of among the space-faring nations, and also the all interested parties, where a consortium has been built, and several of such data sets, that means a global harmonized definition of cities and settlement, global settlements, global urban climate, and then population map, and then the urban metabolism, and also the poverty mapping. These kind of ready-to-use maps, they are going to come. I'll just show some example. We have got presently, it is available, that is the Atlas of the Human Planet. Okay, and it is based on GHSL layer, which is one can download, one can visualize, and also one can analyze the trend of population, and that is the temporal, and also the trend of the built-up. Is ready to use data about the settlements and also its population characteristics. Okay, so what we try to do, such kind of spatial data sets which are available from 1972 onward, but ready to use data is available since 1980s onwards. Okay, so what we try to do, some of these data sets like the Landsat data, Indian remote sensing satellite data, night lights data, all these kind of data we have trying to put into a platform called our own platform, that is called Urban Informatica, where we are trying to map how the built-up change is happening in a city. If that built-up change is happening, what it is effect on the green spaces, what is the effect on the water bodies. If that is so, then using the drivers as defined by the user, what will be the future sprawl of the city. Okay, and then another data set is the nighttime lights data. No, what we try to do, we try to correlate this nighttime NTLS data with the socio-economic attributes, and we try to see that what it is the growth trend of the night lights in different cities in the country. And this all data sets are available in the public platform. We have tried to integrate and bring into a single platform, and we also, in times to come, we are going to develop our own data sets. So it is kind of ready to use data, and one can choose the study area and then find out his raw and analyze attributes and straight away get into, for example, that what will be the growth of the city in time 1, time 2, in past and presently, and in the times to come. So this kind of growth analysis, and then it's socio-economic nighttime lights data and socio-economic attributes correlation. Such kind of ready to use data we are developed on our own platform called Urban Informatica. So it is also hosting the data from the Sentinel, Sentinel 5P precursor, that is again is a venture. I mean, it's the data which is made available by the Copernicus program, and it has got a spectroscopy based sensor which it maps the NOx, SOx and the particulate matter in the city. And then you down below you are seeing the a part of the city where two time domain, because we have passed through the very difficult times in the last year and some part of this year as well, that when the COVID across the world, coronavirus has hit the human population and as a pandemic. So we try, and there was a almost shutdown. So during that lockdown phase 1, how the pollutants, they got decreased, and subsequently in the lockdown phase, how the pollutants, they have got increased. This kind of map, Sentinel 5P data, we also try to ingest into the Urban Informatica platform. Now, in the times to come, our quest for data, because as such, as I said in my deliberation, though there's ample data available in the optical domain, but still the data is scarce, particularly in the high spatial resolution in the hyperspectral remote sensing and in the micro remote sensing domain. Okay, and their data is also scarce in terms of creating the 3D city model. Okay, so, and also data is scarce for understanding the climate, particularly the urban climate. That means variation of the climate as we go within a city. That means within the lanes and by-lanes, because each lanes and by-lanes, it has got its own cooling and the wind related phenomena. That's how the local temperature regime, because of the density of building, also changes. If that is so, this also, it causes the thermal comfort or discomfort to the urban dwellers. So this kind of analysis, no, there's a quest for data. So we have tried to list here that such kind of data sets are required for an effective urban planning, and also to meet the requirement for carrying out the high-end research in the urban areas. With this, I'm concluding my 1 hour long deliberation. I'm thankful to you all. Thank you.